Yeah, so thank you. I'm very happy to talk here and to present this story to you today. So I'm from Roseman Labs. We are a Dutch company that sells basically MPC products in the real world. And I want to talk to you about this case that we did about analyzing Dutch public transport data with multi-party computation. And the story that I'm going to tell you, I can already tell you, has a happy ending. So it ends here at the Dutch Privacy Awards, where actually our customer, who is an organization that organizes public transport in the north of the Netherlands, they won the Dutch Privacy Award, which is a profit awarded by some kind of non-profit organization on using privacy preserving or on privacy in general. They won this award by using our technology. And that's the person on the right. Person on the left is Freya, who's working for us. And she also got the Holte trophy. So they actually won the trophy was won by our customer by using our technology, but our employee also got the Holte trophy in her hand, which makes for this nice picture. So that's the happy ending of this story. But that's not where the story starts. So the story actually starts somewhere very different. Right at around 2017 at the Technical University of Eindhoven, where Nick, who is also here in the audience today, he was working as a postdoc with Barry. Barry, you might know, has this Python framework for doing multi-party computation. And Barry, Nick was working on this, and basically Nick got the idea, why not implement this Python thing in C++, basically to get a better performance. And so the starting point several years ago is a very, very technical one. There's just one guy hacking away in C++, making a more efficient version of an arithmetic black box. And then several years later, we get to actually use this on real personal information protected by European privacy legislation. So the question I want to talk to you about today in this talk is how do we get from A, this very technical starting point, to B, this kind of very practical application. So that's kind of the motivating question for me in this talk. What do you actually need from an MPC product when you're trying to sell MPC really in the real world, except for the actual multi-party computation, the actual arithmetic black box computation. Of course, we don't also have the perfect answer to this, but I think this case that I will talk to you about today highlights several interesting things you can see when trying to apply MPC in the real world. And maybe some of you were also at this workshop 2 years ago when Mark actually gave a presentation about human trafficking. There was another case that we did 2 years ago. Actually, the kind of questions that we had and that we were solving in that use case were pretty similar to the ones today. There we solved them really for a specific kind of use case. We were able to get everything together in that use case, but it was kind of complicated. But nowadays we have a product in which kind of all of these aspects somehow come back. That I want to show you a bit about. Right, so let's talk a little bit about the case. So what is the case? It's about Public Vervoer Groningen Drenthe, which is this non-profit organization from the north of the Netherlands. And basically what they're doing is they're trying to arrange public transport in a good way. So they're trying to arrange that everybody who wants to have access to public transport has that. And one of the things that they organize is subsidized taxis, so meaning that elderly people or people who have disabilities, they get to use these subsidized taxis to travel from A to B. And they were running this pilot project. This was something that was already running before we got involved. There was a pilot project to find out actually, can we replace these subsidized taxis in some cases by just common public transport. So what if you give somebody a free public transport ticket? Would they use this instead of these subsidized taxis, or could they not use it instead of these subsidized taxis? So that was the pilot project that they were running and that they were working on. And in the context of this pilot project, they wanted to answer this question. They had this experiment, and they wanted to know by doing some data analytics, will this work as an alternative to this public transport cost? So that was the case. Pretty classical MPC case in the sense that there are several different organizations. They all have different data, and then of course the question is, how can we combine that data and do a joint analysis on that? As who are the parties and what kind of data is involved here? So we have this Public Vervoer on the top. That's this organization that runs these taxis. So they have actually data which tells you who was driving in which taxi at which date. Then there's the municipality shown on the right. I think in this pilot project there were in the end 7 different municipalities who participate, and they have demographic information. So they know the people, they know their birth dates, they know where they live, that sort of stuff. Then there's the public transport data itself. So on the left there's a public transport company. They know who travels where, when, using the public transport card. And then for good measure, there was also some public data that needed to be included in this case as well. So those were the data, and then the question is to do some analytics on that. And if we look at it a little bit more kind of schematically, kind of data look like this. So we had some demographic information from several different parties. We have some locality information. That's this public data set that basically tells you for a given zip code whether it belongs to a city or a village. And to the right, we have the different transport data and the public transport rights and the taxi rights. And all of this data is then being linked together by identifiers. So basically, we have these different tables of data, and we want to link those different tables of data together and then do some analysis on it. That is actually, I think, the first need that we kind of quickly discovered with our company, that if you want to, before you can start even doing anything interesting on your data, you need to support tabular data. You need to make it easier for people who have data in tables to link them together, to do basic stuff on this, like filtering the data, like joining, like concatenating, all of those basic operational tables that you need to make very easy for your customer. Of course, this is not a new lesson. I mean, Cybernetica was already doing this 10 years ago, and there's other competitors who are doing the same thing, but still I think this is a useful thing to realize that in practice, if you have support for tabular data, that's kind of the basic thing that you start with. And that's also what our product then in the end is centered around. So if you look at what our product basically looks like, so the MPC core of our product looks a bit like this. So we have our kind of our application engine that is doing the actual multi-party computation. So in its most basic form, it's just 3 different servers running an MPC backend. In the most basic form is just your secret sharing, honest majority, 3 parties, specifically secure. Of course, you can use different backends as well, but this is the most basic form. And the way in which you interact with this engine is by calling operations on it. And these are operations that act on tables. So you have this API by which you can actually talk to this backend. You can, for instance, do that using a Python front end. It's modeled on Pandas, which is a well-known package in Python for working on data. And kind of the basic flow is always the same. You upload data, so basically you secret share it into the engine. Then you run operations on tables. I'm calculating here a new column based on an existing column. And then once you have your result, you open it basically. So that's the kind of basic framework that you always follow. And then the security model that we have is that we assume kind of that the metadata that you have that is public, so which operations are performed, which tables there are, what sizes there are, what columns there are, that is all public. And what is then hidden by the multi-party computation is the actual values inside those tables. And basically then the game is to implement a lot of these different operations. Some of them come from the literature. In the literature, of course, there's a lot of stuff being done about combining, about joining tables, about doing filtering, all of that stuff you can find from literature. That's also what we look at very closely from the literature. So our call to you is to implement as many of those, or to find out implementation or efficient ways of doing those operations as much as you can. And then there's also other stuff which is easy to do, other stuff where we have to do our own kind of research to figure out how to do it efficiently. But that's the basic, that's kind of the basic idea. So is this then good enough? So we have our MPC application engine, we have our way of getting data into that system, out of the system. Is that then enough? Maybe it is enough for a data scientist. So for a data scientist could work at this, but what we very quickly discovered in a case like this, where you have 10 different parties inputting data, they're not all data scientists. They're just people from municipalities. And basically you cannot ask them to use a Python front end. We tried to do this actually, but initially, but that turned out to be very difficult. What you really need to have, apart from the MPC part, is just a way of making it easy to upload your data. And maybe if you were there 2 years ago, you may remember this human trafficking case that we talked about. It was very complicated at that time. What we did at that time, we had different parties. Our employees went all over the country with USB dongles, with their own laptops. We made screen recordings, everything to get the data securely into the system. That was early 2022. Then it was very complicated. And actually, it was still complicated when we were doing this case in the end of 2022. We tried to make this Python package to give it to people from municipalities and say, just use this to upload your data. That didn't really work. You get problems with application permissions, with firewalls. In the end, it got so bad that somebody just asked, this is so complicated, can't I just email you the data and then everything will be fine? But we didn't do that, of course. In the end, we got it to work. And nowadays, if you look at our product now, we've made it now very easy because now it's just a web portal. So now we just have a website basically where you can just log in, upload a CSV file, and then it gets uploaded into the system. And then, what happens is basically that the client side in the browser, data will be secret shared and put into our system. So that turns out to work. So people are able to use this system. So that means that we can now go to the data analytics. Except not really, because and that also happened in this case. There's a lot of difference between what people think that they upload and what they actually upload. So what in this case we had 7 different municipalities. They have to upload dates. They have to upload a column in their CSV file which contains the date, the birth date of the person that the entry was about. But of course, when you upload something, it's not actually a date. What it actually is a text representation of that date. Or it can be a different text representation of the date. So this is what actually happened in this use case. We had 7 different organizations. We had, I think it's 5 or 6 different unique representations of dates. We only discovered this after the data had been uploaded into our platform. So we couldn't really ask them to redo it again. So basically we had to find a way to make this work. I think if you generalize this from a little bit more, I think the lesson is you need to have some way of doing data validation. And that is, of course, you always need data validation, but the problem, of course, with MPC is that you've encrypted, secret shared your data, so you can no longer see it. So how can you still do data validation? That remains difficult. I mean, we don't have a perfect solution to that either. Basically, I think there's 3 different kind of directions you can go. You can try to validate beforehand. When people are uploading data, try to see it then, because that's when you can actually see the data in the plane. You can try to inspect data, so even while keeping it encrypted, you can try to find ways of showing what the data looks like. That is what I'm showing here on the left. That's actually a picture from our presentation of 2 years where people had to upload names, and we tried to show them somehow how those names kind of were structured without actually showing their contents. Or, and that's what happened in this use case, you can do post-processing. So what we ended up doing in this use case, people had uploaded their dates in these different formats. We just asked them their permission. Look, can we just open one of those cells to see what the data looks like? We got that permission. And then for each of the different municipalities, we had to do some post-processing to extract the right information to get actually the year that we want to have using the data. All right. So now we're able to upload data into the system to get it into the right shape and to do data analytics on it. So can we now then execute that? Well, there's still one thing missing, which is the actual approval to do that, right? Because data is personal information, as we have here, is covered by privacy law, and you need to get permission to actually use data to actually perform analytics on the data. And that approval comes in 2 different aspects: a kind of a technical aspect of that and an organizational aspect. So the technical aspect is, so can we design the system in such a way that this data analyst, and we provide them all these different data operations. They can compute new columns, they can train models, they can do whatever they want. So we need to have some kind of control on what can they do and what can they not do, so that the organization will upload data, have some assurance what happens. Our system has an open operation, but you're not supposed to use that just on the input data. So that's then the technical part. And then the organizational part is to actually get the persons, the decision makers inside those organizations, inside the municipalities. So the people have to decide, okay, is it now okay to upload this data? Is it now okay to perform this analysis, to get them to basically give their approval for it? So that's the organizational part. And so if we look at the technical part, there's several different ways in which you can do it. The one that we used here in this part is script signing. So basically the idea is that you that we use a signed script, and you're only allowed to perform an analysis once you've gotten approval. So the security model here is that there's different approvals set up. In this case, the project manager of this public organization was the approver. So she had to give kind of a cryptographic signature on the script that told us what analysis was going to be. And the way that works in practice is that you perform the analysis, but you do it on dummy data. You kind of record that analysis, that records the different steps that analysis consists of. That is put in a file. That is being cryptographically signed. And then what the application engine does, when it's being used on actual data, it will only allow you to basically reperform that script. In that way, we make sure that the people who need to decide if something allowed or not, that they can control what happens actually to the data. There are some challenges here. Of course, the person being the approver is not really a technical person, so you need to present the script in such a way that this person can make a meaningful decision on it. That is always a little bit of an issue, but at least you've narrowed the risk down from principle just giving somebody a CSV, for instance, like you would do traditionally, to just saying, okay, there's this one script that is being approved, that is something you can now execute. So that is the technical part. Then there's also the organizational part, which is you have all these different organizations. We have, I think, 8 different organizations in this pilot who contributed actual personal information covered by Dutch privacy law. So you need to have approval to use that personal information in your analysis, actually. And that takes, in the GDPR, that takes the shape of a so-called data privacy impact assessment. So that's basically a kind of legal document in which you exactly describe what is the data analysis you want to do, what are the risks associated to it, and you need to make a trade-off between those things, and then in the end conclude whether or not you can make the data analysis go through. And our pitch kind of then to our customers is that MPC helps you with this impact assessment. It's not the case that you don't need such an impact assessment anymore. You're still processing personal information. You would still fall under the privacy legislation. But because you're kind of using data minimization principle, right? Because you're only using the data, the minimum amount of data that you need to perform the analysis, and because you keep people in control of what happens to the data, even though it's being processed somewhere else, that's actually what helps you to get through that privacy assessment. So that's kind of the sales pitch that we have. But you still need a legal ground to be able to process information, whether that's consent, whether that's legitimate interest. That can differ from case to case. You still need that, but MPC can help you make that easier. That's our pitch. But actually, what we find in our day-to-day cases, that legal ground is not really the problem in practice. So in this case, it was even very easy. This was a pilot project in which the participants in that project had kind of signed a consent form to participate in this analysis. So there was even explicit consent, but probably legal ground or legitimate interest would also have been okay in this use case. What we found is that in order to get this DPA to go through, to get this actual approval, it helps if there's an actual need, if people actually need you to do this data analysis. What was interesting is that one of the municipalities, had been talking to them already for months. We just demonstrated, we have this very cool advanced technology, it's called multi-party computation, you want to try it? They said, yeah, very interesting, but making it actually happen, making the pilot actually happen, that turned out to be very difficult. But then things changed. They had this pilot, they needed to do this data analysis, they needed to have the results actually, and then it became way easier. Then we went through the DPA quite quickly and got approved to work on the actual data. And actually what was also interesting in this pilot is that there was an alternative. So they did not need to perform the data analysis as we did. If the DPA hadn't gone through, they had an alternative, which was simply to do surveys. So they wanted to find out whether people were changing their behavior in this pilot. What they were originally planning to do was to do a survey, to simply ask people voluntarily to fill in their survey responses. And they were planning to still do that originally, to compare it to this, but it turned out that actually using the multi-party computation was so much easier. They already had this done that they thought, let's just forget about this whole survey. So there, actually multi-party computation in this case really helped them to perform their data analysis in an easier way, which was a nice result. What was true and what you also see is that if if you have different organizations, each of them individually needs to make the decision. Okay, is it okay to use our personal information that we manage to put that into the system? Different organizations make different choices there. And that is because, yeah, it's different people. In the end, it's a legal choice. It's not something you can that has a binary answer. It's a matter of risk. It's also a matter of differences between who inputs what data, because if your data is more sensitive, there's more risk associated to allowing it to be performed in such a way. That's also what happened in this case. So in this case, we got approval from the municipalities. We did not get approval from the public transport company, maybe because of privacy risk. There was also kind of legal questions about what kind of personal information this actually was, and that can make a difference for the privacy law. So in the end, they did not give us the approval, but all of the municipalities and also this public vervoer organization, so the organization with the taxi rights, those did give us the approval. But that was enough to do the actual data analysis. And maybe just very briefly look at what the data analysis actually looked like. So going back to the different data that we had. So I've removed here the data from the public transport company, so the data about the taxi, about the bus use and train use, because we were not able to use that. But we were able to use the data about the taxi rights. We were able to use the data from the municipalities about the demographics, about the different people. And we also used this public data set, this locality data set, which showed you for a given zip code what type of zip code was it. Was it a zip code from a city or from a village? And basically the question that we wanted to answer here is over all the different municipalities combined, and per year, they wanted to have some kind of per year statistics. What is the total distance per traveler who has a given locality type? So basically they wanted to split up the data per locality type. They wanted to do an aggregate per traveler, and they wanted to have this for all the municipalities combined per year. And yeah, and this was done on the data. I don't even know exactly. This was maybe 10,000s, 100,000s of records. I don't know exactly, but not something to be very worried about. And if you look at what this looks like, basically this can be done, can be implemented pretty much in terms of pretty standard operations and tables. Basically what you do, you want to do it over all municipalities, so you combine all the demographic data, you concatenate all those tables, and you want to do this per year, so that means filtering taxi rides per year. You want to have the total different distance per traveler. What that then means is you have the identifier of the traveler here, that says pass ID, and you basically just do a group by. That's also something you can find in the literature, but we have an improved version of that in our product. And then basically you join all of those things together, and you open up the results. So basically just using kind of standard table computation operations, you can do performance analysis, and what comes out, I've anonymized the graph a little bit here at the request of the customer, but you get a very nice graph. This is the graph that actually turned out in the kind of final project report of this pilot project. So that was, I think, yeah, a nice outcome of this pilot. So maybe to conclude, maybe first a few words about the project. So the project went successfully. It was awarded this privacy award, as you can see, basically for the first time in this kind of application area using these kinds of technology. So it was kind of a nice recognition. And the project will also later be extended, at least that's the plan, to include additional municipalities and also the transportation companies who now apparently, now that they saw that everything went correctly, nothing bad happened, they probably also want to use their data. So that's the conclusion about the project, and maybe a few words about the company as well. So the company has now grown a lot over the past years. This is a pretty recent picture. So it has grown a lot with a lot of people that I never knew you would need in the company, but apparently you do. We have DevOps people, support, sales, marketing, user interface people, web development people who make this web portal, we have management people. So there's a lot of different people, and they have a lot of different perspectives, and I think that really helps to actually, understand, to make a product that in the end can be used by normal people. And apart from that, of course, we have cryptographers as well. So we are all a little bit in the background, but we are there. And those are actually the people that are also here at this conference. You see Toon here right at the left. Then standing in the back is Esteban, me, Nick and Aldo. And to the right there's Mark. So we're all here at this conference. Please talk to us if you want to know more about the company. I'm sorry? The dog is not doing crypto at the time. He's interested, but he's not doing crypto. Maybe next time. So that's it. Please talk to us if you want to know more.